Hello Earth Science students. Today we're going to be doing a lesson on climate. We're going to start with factors that affect climate and then move on to things that can influence climate change on Earth. So we're going to be using the front and back of a piece of notebook paper, a pencil, and then if you have your highlighters, you can use your highlighters too. So we'll start off with factors that affect climate. Okay, let's go ahead and put a good definition for what climate is. That's supposed to be a star. Climate is just long-term, stable weather patterns in an area. So this is like we say that in Helena, Montana, we have a semi-arid or dry climate because over a long period of time we've measured that we don't get that much precipitation, so we have a dry climate. So it's just stable weather patterns in an area. And then when these weather patterns begin fluctuating, it's just called climate change. The climate is being changed by something. So first we'll talk about the different ways that climate can be affected. So I think we'll fold our paper in half once like this, so 1/2 hot dog, and then from there into thirds, so that when we open it up we'll have 6 nice sections, because there are 6 factors we're going to talk about that can affect climate. Alright, so first in this top section we'll do latitude. So basically distance from the equator. As latitude increases, meaning you get further away from the equator, the latitude is 0 at the equator and 90 at the poles, so as you go further away from the equator, climate gets colder. Okay, we're going to talk about 3 zones, climate zones based on distance from equator. First is tropical. This is from 0 to about 23.5 degrees. That's very warm in this region. Then we have temperate, which is from that 23.5 to about 66.5 degrees. So Helena, Montana is going to fall within this chunk here in the middle latitudes. And then polar, which is from 66.5 to 90 degrees. So like I said, maybe we'll just put a little star by this one. The star means Helena. Where we live, we fall within that temperate zone. So these hot, not as hot, kind of hot and cold, and then very cold, depending on how far you are from the equator. Next, we'll go on to elevation. So this is like how high up. Basically, as elevation increases, so the higher up you go, climate is cooler. So that's why it's like very snowy and cold at the top of Mount Everest, because it's very high up in the atmosphere, and so it gets colder as you go up through the troposphere, as we have learned previously. Okay, next we'll move on to topography. So in our next chunk here. And surface material. So topography has to do with like what is the bumpiness of the terrain essentially. And so in this case we'll talk about mountains. So again, like we've learned before, that's an interesting S there. Mountains can cause rain shadows. We'll say rain shadow deserts. So remember, just like Helena, we are in the rain shadow desert of the Rockies, because remember the prevailing winds blow moisture from the west coast of near the Pacific Ocean towards Helena, but they got to get over a couple mountain ranges first before it can get to us, and so the air is dry by the time it gets to Helena because it's had to go over those mountain ranges, and it dumps a bunch of moisture each time it does that. So another thing is albedo of surfaces. So if you have surfaces that have high albedo, then you get a net cooling in the area and a cooler climate. So for example, snow and ice, things that have high albedos like snow and ice, it's cold to get the snow and ice to form there, but then once the snow and ice are there, it has like a compounding effect because these are high albedo, so they reflect a bunch of radiation away, and so it's kind of like a a runaway process of, you know, being cold to form the snow and ice, and then the snow and ice make it colder, and so more snow and ice can form, and so on and so forth. Okay, next we will do water bodies. Okay, so water bodies, large bodies of water. For example, oceans or really big lakes like the Great Lakes cause climate moderation. Meaning that it's like less hot in the summer and less cold in the winter. Because if you remember from the Heating, Land and Water Lab that we did quite a while back, water heats and cools slowly. So during the summer when it's heating, it doesn't heat up as fast, so it stays cooler, and during the winter when it's cooling off, it doesn't cool off as fast, so it stays warmer. So this is why places that are near bodies of water have a more mild climate than places that are landlocked. Okay, next we have atmospheric circulation. So this is like that global winds lab that we did a couple weeks ago. So basically, atmospheric circulation moves warm air toward the poles, cold air toward the equator to kind of moderate the climate, because remember, it would be way too cold at the poles and way too hot at the equator if we didn't have this circulation of warm and cold air to balance things out. And then last we'll go with vegetation. So the amount of vegetation that's present in an area can influence the climate, because plants absorb solar radiation to do their photosynthesis thing, right? They've got that green pigment chlorophyll in their leaves that absorb solar radiation to do photosynthesis, and they also do transpiration. Remember, that's evaporation from plant leaves, and this causes cooling in the area because a lot of heat has to be absorbed in order to get water to evaporate, so it causes cooling in an area. And then also pollen and other like plant dust and debris can act as condensation nuclei, which can help encourage cloud formation. And the more clouds there are in an area, the more radiation is reflected, and then also precipitation can occur, which again is cooling to the area. Okay, we'll flip to the back now, and we'll move on to things that can cause climate change. So climate change, we'll just define this as a disruption in the stable weather patterns of an area. So climate change can be short-term and temporary, or it can be long-term and more permanent, but the Earth has gone throughout many different cycles of the climate changing for various reasons, and so we'll talk about some of those. So first, let's talk about some natural ways that climate can change. So things that are completely outside of the control of humans, we really can't do anything about these. They're going to happen no matter what. So we'll start, first we'll do some short-term. So these would be like easily observable on a human timescale, short-term reasons for climate change. First, solar activity. So the sun goes through an 11-year cycle of more or less sunspots. So we can get these kind of 11-year patterns of temperature change based on sunspots. So sunspots are storms, big magnetic storms that are on the sun that indicate the sun is like going a little bit crazy with its energy. And so more sunspots means more radiation, which means you can get some warming. coming from the sun over this 11-year time period. Okay, and this just cycles. It's just the sun is doing its thing, and so we get these kind of 11-year chunks of time where there will be more or fewer sunspots, and that can influence global temperatures a little bit. Next, we'll do ocean circulation. So this is like the El Nino and La Nina that we talked about previously. And so remember that El Nino for us in Montana, it causes it to be drier for this, it's like a 3 to 7 year cycle. And La Nina will cause it to be a little bit cooler and wetter, and so the ocean just influences the global climate pretty strongly. Next, this is our last short-term natural one. We'll put volcanic eruptions. Volcanic eruptions is going to show up in both short and long term, but a short-term climate effect of volcanic eruptions is that the ash and dust that they spew out are very high albedo. So you can get a short-term cooling after a volcanic, that's a really nice E there. You can get a short-term cooling effect after a volcanic eruption because all that ash and dust they spew out into the atmosphere are really reflective, so they reflect a lot of solar radiation. They encourage cloud formation, and so you don't get as much radiation reaching the surface. Next, long-term. More long-term natural causes of climate change. First is plate tectonics. So plate tectonics means like the plates of the lithosphere that are moving around and they're doing their thing, floating on the top of the mantle. And so when you get mountain building, so when two plates hit into each other and then push each other upwards to form mountains, all of that fresh land that wasn't previously exposed to the atmosphere is really good at absorbing carbon dioxide from the atmosphere, and so you can get some net cooling, because we know carbon dioxide is a greenhouse gas that warms the atmosphere. So if you've got mountain building absorbing a bunch of carbon dioxide, that can cause some global cooling. Next, Earth's orbit. So the Earth's axial tilt that's at 23.5 degrees right now, it kind of wobbles a little bit, more or less, and then also the orbit around the sun can become more or less oblong. And so as Earth's orbit changes, we'll just say more or less elliptical orbit and more or less tilt of the axis. So if we just end up being closer to the sun during any of this, you can have a little bit of global temperature increase going on. And so now here we'll have our long term for our volcanic eruptions. So the gases, especially like sulfur dioxide gases and stuff that come out of volcanoes when they erupt, can destroy the ozone layer. And so we know that the ozone layer blocks out a lot of solar radiation. It absorbs it before it can get to the surface of Earth. And if more radiation can get to the surface of Earth because the ozone layer is not blocking it, then more can be absorbed by the Earth and re-radiated as infrared heat that can then heat the atmosphere. And then also just plain old greenhouse gases come out of volcanoes when they erupt, like carbon dioxide and water vapor and stuff like that, and those are capable of causing warming over a longer period of time. So these are all of the different types of natural climate change we're going to talk about, and then we also have to talk about anthropogenic. Anthropogenic means man-made or human caused. So this root here, anthro, like anthropology, has to do with man, and genic is like genesis, like the beginning or causing of something. And so anthropogenic is just man-made or human caused climate change. So we can, with our little human activities that we do, we can cause warming of global climate by producing greenhouse gases. So for example, like when we burn fossil fuels, or remember we talked about livestock, so conventional Remember, if you feed cows the wrong thing, then they fart way too much methane out. So when we do stuff like burn fossil fuels and grow livestock by feeding them the wrong stuff, we can cause warming of the atmosphere because we're producing greenhouse gases that can warm it up. Or humans also have the capability we can remove greenhouse gases. Because humans, we are very smart, and we can come up with technologies that can remove greenhouse gases from the atmosphere. So for example, carbon capture technology. We have, and we could further develop things that can pull greenhouse gases out of the atmosphere to cause global cooling. And so, like humans, we're just little animals. We're just a small percentage of the total biomass on the earth, but we can pretty strongly influence what the temperature of the atmosphere is doing by producing greenhouse gases with our stuff, but we could also cause some cooling by removing greenhouse gases on purpose.